Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 145, locate the centroid Y, barred Y of the beam's cross-sectional area and then determine the moments of inertia of this area and the product of inertia with respect to the U and V axis. The axes have their origin at the centroid C. So let's divide for our solution the area into this manner. We have vertical lines here. So the area is divided into that manner. The area here is 25 times 2000, so 5000. This is also 5000. And this is 25 vertically by 100 mm as 150 times minus 2 times 25, so 100. 100 times 25 is 2500. Therefore, the total area is 5000 times 2, or 5000 plus 5000 plus 25 equals 12,500 mm square. By Varigton's theorem, 12,500 times barred y equals 5000 times 100 plus 5000 times 100 plus 25 times half of 25, 12.5. So barred y can now be computed. It is equal to 82.5 mm. Then I sub u, by the way, 2 theta is 2 times negative 60. 2 times negative 60 is negative 120. So I barred x is 2 times 25 to 100 cube over 12 plus area 5000 times quantity 100 minus 82.5 square. Then for this rectangle at the bottom, plus base 100, height 25, so 125 cube over 12, plus area 2500 times quantity 82.5 minus 12.5 square, where 12.5 is the centroid of the bottom area from the bottom. So calculating, I bar x is equal to 48.776 times 10 to the 6 millimeters to the fourth. I bar y, on the other hand, is equal to, for the two vertical rectangles, 2 times quantity 25 cube times 200 over 12 plus 5000 times quantity 75 minus 12.5 square. 75 is distance from the y-axis to the outer edge of the vertical rectangle. Then since the centroid is at the center of 25 mm thick, so 75 minus 12.5 square, plus for the bottom rectangular area, there's no need to transfer. It is just 100 cube times 25 over 12. So I bar y is equal to 41.667 times 10 to the 6 mm to the fourth. Then I sub u, remember 2 theta is negative 120 degrees, theta is negative 60 degrees. So I sub u is, product of inertia is 0, by the way, because this U-shaped section has axis of symmetry. So I sub u, I bar u is 1/2 quantity, 48.776 plus 41.667 plus 1/2 quantity 48.776 minus 41.667 cosine of negative 120 degrees, then plus 0. So you'll just calculate this. I bar u is equal to 43.44 times 10 to the 6. I sub v is 1/2 quantity 48.776 plus 41.667 minus 1/2 quantity 48.776 minus 41.667 cosine of negative 20 degrees plus 0. So I bar v is equal to 47 times 10 to the 6 mm to the fourth. Then PUV is 1/2 quantity 48.776 minus 41.667 sine of negative 120 degrees plus 0 cosine of negative 120 degrees. So formula, I hope that you can now remember the formulas for I sub u, I sub v, or I bar u, I bar v, and p uv and p bar uv. So calculating p bar uv is equal to 3.078 times 10 to the 6 mm to the fourth. Level 146, determine I bar u for the inverted T section shown. Note that the section is symmetric about the y-axis. So the centroidal product of inertia would be 0. Theta is positive 45 degrees. And let's divide the areas into this one horizontally. So for our solution, the area 1 is 16 times 4, so 64. And call that bar y 64. This is also 16 times 4, 64. So by Varignon's theorem, 64 plus 64 is 128. 128 bar y equals 64 times 12 because this is the centroid of the upper rectangle. Half of 16 is 8 plus 4, so 12. 64 times 12 plus 64 times 2. So bar y is equal to 7 inches. Then for I bar x or I sub cx, we use parallel axis theorem for the upper area. 4 times 16 cubed over 12 plus 64 times 12 minus 7 square. So I bar x equals 4 times 16 cubed over 12 plus 64 times 12 minus 7 quantity square. For the lower area, 16 times 4 cubed over 12 plus 64 times quantity 7 minus 2 square. So I bar x can now be computed. It is equal to 4650.67 inches to the fourth. I bar y, there's no need to transfer, so it is just 4 cube 16 times 16 over 12. 4 cube times 16 over 12 plus for the other area 16 cube times 4 over 12. So 16 cube times 4 over 12 for the lower rectangle. And I bar y is equal to 1450.67 inches to the fourth. Formula for I bar u is equal to 1 half quantity I bar x. Product of inertia is 0, by the way, because it has an axis of symmetry. I bar theta is 45 degrees positive. I bar u is equal to 1 half quantity I bar x plus I bar y plus 1 half quantity I bar x minus I bar y cosine 2 theta minus p sub xy, p bar xy sine 2 theta. So we just replace this by centroidal, so barred everything. P bar xy is 0. Then ix and iy are centroidal moments of inertia. So I bar u is equal to 1 half of quantity 4650.67 plus 1450.67 plus 1 half quantity 4650.67 minus 1450.67 cosine of 90 degrees, then plus 0. Calculating, I bar u is equal to 3051 inches to the fourth.